Welcome, my name is Nicholas Sayer, and today I'll be showing you how I solved the first extra credit problem from my engineering programming course at the Oregon Institute of Technology. Now this problem's on movie tickets, and the core of it is really a random function that spits out values between 0 and 1. You can use that by just plain old RAND, and the core of the function is to 200 times, one for each person in the line, roll the RAND value, and if it's greater than 0.5, the cashier removes a 5 from the till. If it's smaller than 0.5, which is the else condition, he adds 1. And so if at the end of 200 he hasn't run out of money, hasn't gone negative, then he succeeded. And I added this bit right here, is that the loop will terminate if it ever goes negative, because there's no reason in going all the way through 200 people if you're out of money. That'll help lighten up the computation. And then here I made, with this overarching loop, I made the number of 5s in the till variable, so that you can try a large variety, a large range of numbers, maybe with a small number of trials, and kind of just home in on the number of 5s that you need. And that was just the first time was said 27 and a 95% chance of having enough 5s. So you can't get much better than that. You can run it again. At the low number of trials, though, it kind of flops around at different values, at 30, 26. But you can run it at a high number of trials, and I did at like nearly 1 million, and ran it all the way through, all the way through 1 through 50, and to see which one was the best number of 5s, and it still gave 27. And with this you can run it, however much you want. Anyway, the final part was to compare the different number of 5s, because each one's going to have its own different success rate. So after you've gone through all 200 people, you do a calculation here, which was the difference between the desired percentage, in this case 95%, and the actual success rate, which was the number of successes over the number of trials, and then comparing that to a best known number of 5s. And if it's better than the best known, then it becomes the new best known. And then at the bottom, just displaying how many 5s it comes to. So there you have it.